Welcome to springlib.
This is the answer to Chapter 30, problem number 34 from the Smith Organic Chemistry textbook. And in this problem, we're given four molecules, they're Decalin derivatives, and they have defined stereochemistry in each molecule. And we're asked to draw a three-dimensional representation of each molecule and to note particularly the stereochemistry of the alcohol. And so we're talking about six-membered rings, and we're talking about three-dimensional structures. And so these are going to be chair structures. And so to get started, the first thing that we should do for each of these is to draw the chair. And so we have two fused chairs, and remember that so because in the structures that we're given, the hydrogens are trans to one another, we're going to have the chairs in their most sterically favorable conformation. So the chairs are going to be connected to each other so that each carbon-carbon bond is equatorial. And so what that means basically is this hydrogen here is going to be axial, and then this hydrogen here is also going to be axial. And so that allows, let me highlight them in green. That allows this green bond and this green bond to be in the equatorial positions of those respective carbons with respect to this first ring, if that makes sense. And that's, of course, what we would expect, because an entire second ring is going to be, quite a large substituent. And so sterically, it's best for that to be equatorial. And so that's going to be the case in each of these molecules. For all four of these Decalin derivatives that were given in this problem, the hydrogens are defined as being trans to one another. So in each case, the fused ring structures are going to be exactly the same. So all that's going to change is the position and stereochemistry of the alcohol. And so here for A, we're told that the alcohol is on a wedge. And so this hydrogen that we looked at to start with, that was wedged and is axial. So a wedge at this next position would be equatorial. A wedge at the next position would be axial. And then so here again, finally, where this alcohol is, we see that since it's wedged, it would be equatorial. So there we go. We can draw it equatorial and put an E here, since the problem is specifically asking us to address whether it's equatorial or axial. Just get rid of these arrows so as not to confuse anyone. And so there we go. There's A. And so moving on, that's exactly the pattern that we're going to follow to solve each of the remaining three. So again, we can start by drawing our first chair. And I do apologize. I am not the best at drawing chairs under the best circumstances. And it's even more difficult using the stylus and pad to write on this whiteboard app. And so there we go. There's our fused ring system again. So axial proton, axial proton. So now for B, our alcohol is at a different position, actually one position away from where it was in A. And again, it's wedged. And so right off the bat, we can say, well, that's going to make it axial. So wedged one position away in A was equatorial. Oops. And so here at the next position in B, wedge is going to make it axial. And so there it is, drawn axially. We'll call it A for axial. So then we're going to move on to C. Again, the chair structure that we have to draw doesn't change. So there's our first chair. Chair number 2. Axial proton. Axial proton. Okay. And so now for C, our alcohol is where it was in A at the same position, but this time it's wedged. So if it was, or pardon me, this time it's dashed. So it was in the same position in A and it was wedged and it was equatorial. Nothing else about this molecule has changed. So it's now in the same position once again, but it's dashed. So we should know without really having to do any other work that that is going to make it axial. So I've drawn it axially, and we will label it A for axial. So then just as C compared directly to A, D is going to be directly comparable to B. Oops. So, Jesus. So we can start by drawing the chairs. So there are our chairs. Here are our axial hydrogens. And then again, we can make a direct comparison between D and B as we did between C and A. And so B, it was wedged and therefore axial. And here in C, it's going to be dashed and therefore equatorial. So there it is, drawn equatorially. We'll label it E for equatorial. And that is the answer to chapter 30, problem number 34.